Hey, hi everyone, welcome to Revodu. This is Nitin, and today's topic is scientific method. So, guys, in the previous video, we discussed about science. Science is basically a systematic study of the structure and behavior of the physical and natural world. So, guys, I want you to focus on this word systematic. This word is there for a reason because there's a particular system we have to follow in order to do science. It cannot be random, it cannot be your opinion. All right, so what is the scientific method and why Galileo Galilei is regarded as the first true scientist, why he is regarded as a father of modern science? You'll get to know about all of this in today's video. So without any further ado, let's get started. So guys, in order to understand what a scientific method is, let's take an example of a real world scenario. And this happened to me just a few days back. So I really like plants. And I got this very beautiful looking jade plant, a succulent. And we all know they can be pretty hard to maintain. So what I did, I put that plant on my dining table, and after few days, I realized that plant was not looking so healthy. Its leaves started to fall down, and that made me, worried. So it all started with an observation, and that was leaves were falling down. Okay, they are falling off the plant. So that was the observation. And then I asked myself, I had to answer some questions. There were some questions like, okay, if the leaves are falling off, it clearly means the plant is not okay, it is sick. What could be the reason behind it? Then I made a guess. Okay, my guess was that maybe it is the lack of sunlight. Maybe it is a lack of sunlight which is making this plant shed off its leaves. It is unhealthy, it is squishy. Chicken. Then what I did, I made a prediction. My prediction was, and my prediction was that if I put this plant in a bright region, then it might get better. Okay. So my prediction was, let's put this plant into a brighter area and see what happens. So I tested out my guess. I did testing. I put the plant in a brighter region and then I observed. Basically, I collected data. Okay? Then I collected data and basically saw that it did not help. The plant was still shedding off its leaves. It was still unhealthy, which made me think that it is not the lack of sunlight. The reason why the plant is not healthy should be something else. It cannot be lack of sunlight. So I came back because my hypothesis, my guess was not correct. I came back to my guess and changed. I have to change it. So I had to change it. So my next guess was, maybe I'm overwatering the plant. Okay? I am overwatering. Oh my god, spelling. Overwatering could be the reason. So then I made a new prediction. Okay, if I decrease the frequency of watering of this plant, maybe the plant will get healthy once again. And this time, my hypothesis, my guess was right. I did the testing, and after some days, I realized that it was the plant got healthy looking, and even some new leaves were there. So after this, when I proved okay, it is the overwatering which was the issue, then I could share my findings with my friends and family. Okay, whoever are interested in plants. So you share your results. This entire thing is nothing but a scientific method. Okay, it starts with an observation, then a question, then we have to make a hypothesis. We have to make a hypothesis, then we have to predict, and we have to test our hypothesis. After the testing, Then, or you can say experimentation, we collect data and analyze it. If it matches the prediction basically, then our hypothesis was correct and we can share the result. If it does not match the prediction, then it means our hypothesis was incorrect and we have to change it. We have to come back and repeat the cycle. We have to repeat the cycle till we get a set of result which matches the prediction, which makes our hypothesis correct. And once that is done, then you have a theory at your hand. Overwatering makes succulent sick. That is my theory I have. Then I share this result with everyone. Okay, so guys, in our formal way, what is the scientific method? So, scientific method. It starts with an observation. It starts with an observation. Then we have to ask a question. We have to then make some assumptions, or you can say hypothesis. Then we have to make predictions based on the hypothesis. Okay, if we do this test, we should get this result. Okay, so naturally, the next step is experimentation. Experimentation. Through the experimentation, we get the result and data. So I should write, we get data and we have to analyze the data. Now, there are two possible outcomes after the data analytics. If we get a set of data which matches the prediction, it means our hypothesis was correct. If it does not match the prediction, then we have to come back to our hypothesis and change it and repeat the cycle again. Okay, so if it matches the prediction, then we can share the result, which means our hypothesis was correct and we can communicate this to other people. Okay, sharing the result, or you can say publishing. Okay, that is what a scientific method is. Now guys, you might have heard of some words related to hypothesis. These are axioms, postulates. How axioms and postulates are different from hypothesis. So when I say axioms, so axioms are statements which are self-evident and need not to be proved. Okay, let me give an example. One axiom in Euclidean geometry is, if you take 2 points, then there is only one line which passes through these 2 points. Now, based on this axiom, we can build more theorems. Okay. Now, you don't have to prove. It is self-evident that if there are 2 points, there is only one line. There is no need to prove anything. Okay, that is called an axiom. Then there are postulates. What are postulates? They are very similar to axioms. Postulates are statements which we have to assume true and we don't have to prove them. For example, there is one very famous postulate by Einstein that the speed of light is constant irrespective of the observer. Okay, observer kuch bhi kar raha ho, speed of light is constant even for that observer. That is a postulate. You don't have to prove it. But using this theory or using this postulate, he came up with a theory of relativity. That's a postulate. There are other examples of postulates. For example, in order to justify the observations, Niels Bohr came up with some postulates. One of those postulates is electrons can only be in certain energy states. Alright, there are only certain states, there are certain orbits where the electrons can be. Electrons cannot be anywhere randomly. That is one postulate. Okay, so these are postulates. Then what is hypothesis? Unlike axioms and postulates, hypothesis can be tested. When I say hypothesis is something which we suppose is true and we can test it out. For example, if we give more sunlight then plant will get to grow bigger, taller, healthier. That is one hypothesis which we can test. We can take two identical plants or almost identical plants. We can put one plant in sunlight and we can put one plant in a shade, and see the rate of growth in both of them, and then we can come to a conclusion. Yes, whether indeed sunlight can help plant grow faster or not. Okay, that is a hypothesis. So guys, these words, you don't have to get into too much of these all these words, but a simple idea is enough. Okay, now why Galileo Galilei is regarded as the father of modern science? The answer is this. As you can see in this whole process, this is the most important step, that is the experimentation, the testing of the hypothesis. If there is no way in which you can test your hypothesis, test your guess, then nothing will make sense. Yes or no? So what Galileo Galilei did differently than the earlier philosophers or scientists, he tested his hypothesis. Okay, for example, Aristotle said that rest is the natural state of objects, and if you want to keep something moving, you have to apply you constantly have to apply a force on it. Okay, which kind of makes sense, because if you observe things, if something is moving, it slows down and eventually it comes to rest, which means if you want to keep it moving, you have to apply a force. That was Aristotle's idea. But what Galileo Galilei did, let's test it out. Let's see if it is true or not. Then he did his famous ramp wall experiment, and he showed the world that if you remove friction, you remove air drag, and if something is moving, it will keep on moving for all eternity if it is not obstructed by anything. You don't need to apply a force. If something is moving, it will keep on moving. The things slow down and come to rest because of friction, because of air drag. You remove these elements and see, things will keep on moving without any application of force. So he showed this through experimentation, and this is what he did differently than all the others, and that is why he is regarded as the father of modern science. He did his famous experiment where he dropped two balls. One was slightly heavier than the other, and showed that both of them fall at the same time. They strike the ground at the same time, which means it does not depend upon the mass how fast things will move under gravity. So these are the benefits of doing experimentation. There is no, you cannot deny what you observe through experimentation, what you observe through data. So guys, that is it. In the next video, we are going to talk about what is the meaning of unification of physics and what do we mean by reductionism. Okay, so see you in the next video. Thank you. Bye-bye. See you.